I'm going to kick us off by running the Azure workload command. If you have access to the tool, you can play around with it after this. We have a channel on Slack that you can share feedback as well. So feel free to test it. I'm going to do this little demo, and our dev cluster has been under testing the last few hours. But I think I can do the demo. If not, we'll see the video, which has some of the functionality. So before I start, let's go over what these workload files are. So Azure Workload essentially picks up a workload file, a YAML file such as this, and launches it, right? And launches it is doing a lot of hand waving right now, but we'll get to it in a minute. But essentially, what is this workload file? This is essentially what you provide Azure, what you tell it, I want to launch this. And this is one example that I brought here for our little presentation. So it will include two workload files. So it's going to be two workloads. And this is one of them. And this launches essentially this chat program that you're seeing here. So let's go over it. You'll see this is something that you'll be a little bit familiar, right? So this is not something that will be weird for an engineer coming outside of Moniepoint to see. This is similar to any YAML declaration, either directly on Kubernetes or Docker Compose files. This is something that you'll find familiar. So essentially, I have some metadata here. I have some containers declaration, a service declaration, and some resources. The resources part is our main focus today, but this is the main parts of this YAML file. And so the service is about networking. You know it from Kubernetes concepts. The containers, Docker containers, you know them as well. Metadata is, as you expect, just to identify the workload. And then we have the resources itself that provide you this functionality. So I launched this workload file by doing Azure workload run with a little name, and I got this out. So I have two workloads, right? So it was this file here and this identity file as well, which is a little bit smaller. And I got some information that was deploying, and at the end, I got some port forwarding. If I access this one, localhost 3476, then I got into this chat application. This is just something I generated for the purposes of this demo. But here, this is essentially a chat application that is working. I have a couple of users. I can say hello, and I can see if I log in with the other user, I can see I have a message, hello, and I can reply, hello yourself, right? And this just a basic chat application. Let's see what actually happened. So I'm going to go, I'm working with Omega. So Omega uses the MPT rand cluster, which is our internal cluster for R&D, not the one that we normally use, but for our dev purposes, this is what we use. And let's see what was created. So we're talking about, I got this workload identification, right? Some random numbers, and then Azure demo, which was the name that I passed. And here I can see connecting to this cluster, the R&D cluster, I can see that this namespace was created. So we have this namespace created. And more interesting, I can see in my custom resources, there is something called DX workload, which is essentially what I provided, Azure, right? And we can go over it here. This is the definition for this workload. So it's here, this Azure demo. Sorry, this is a previous one. Let me open this one. And I have some information, some internal information. I have a spec, something related with Crossplane. We'll get to it as well. But I can see here that information that I provided. So that API version, that image that I provided, all the metadata as well. So this is what we created in Kubernetes. We created this custom resource. And then somehow that ended up being this namespace. And if we go into this namespace, I can see these pods. These are the pods that were visible here. So this is actually what I told Azure to create. So we have two Postgres databases. We have some Redis cache. We have a front-end application, which in fact, these are two containers in the same pods. So If I go into them, I can see that I have my backend API and my front-end application. I also have some identity service. This is from the other workload. And I also have a proxy to expose all the necessary ports that I get there. All of this was created as well as secrets. So everything is kind of authenticated. So when you are developing, you can use authenticated resources. You have a bunch of different information here that is specific to your workload. So there is no actual issue of sharing credentials or anything like that. And we have also the services exposed, so we can actually see this inside the cluster, the namespace, but also outside in my local machine. All right. All of this was created by doing simply Azure workload run. So let's actually go and try to see how this works. What's actually happening under the hood. And let's go to our presentation then. So what is happening? I provided a YAML file. I did this Azure workload run. Give me just a second. So I did this Azure workload run, and I got a bunch of pods being created on the cluster, and I can access these pods through this proxy, well, the endpoints that I get, but go to the proxy pod itself. So this was normally something that you would have a lot of configuration to do. As you saw, this was minimal configuration, right? So I had, even in the chat, which is the most complex one, have very little configuration. I provided what image I want. I injected some variables, and then I did the resource and had some initialization script for my database. So one philosophy here first is we are doing mostly convention over configuration. So you guys don't need to configure a lot about it, and a lot of the defaults are kind of assumed by yourselves. You have the option to change a lot of stuff, and we don't need a lot to get started. But essentially, this is what's happening. We have a YAML file, we do this command, it has something to do with Crossplane, and we go into this cluster. So let's go into what actually this works, okay? So that's the topic of today. We're going to be, we launch environments very quickly. So this is something I can test. I can test with different databases. I can test with different dependencies to other services. I can just test, do feature environments. I have a specific version of my application that I want to test. I can test it quickly without affecting everyone else on my team, on the dev environment, staging environment, or even in production, right? So, and this is all based on Crossplane. So let's take a moment and try to understand what Crossplane is, okay? So Crossplane is a CNCF project. It's a graduated project, graduated actually last year. So what this means for those that don't know is the Cloud Native Computing Foundation has these open source projects that they kind of guide through different stages, and the last stage is a graduated project. This means that the project is likely to live on the long run because it has a good user base, a good community around it. The maintainers follow decent practices, and so it tends to live long and be used quite a lot. And Crossplane is one of those graduated projects last year. So they position themselves, if you go into their website, they position themselves as a framework to build control planes. So to build internal APIs for the infrastructure engineers, platform engineers, to kind of then help provide these functionalities to the company. And they also provide a lot of so since this is a graduated project, the community is healthy, and they have a lot of kind of pre-made resources that you can use, and they can integrate with a lot of the cloud providers that you know, like AWS or Google Cloud. So they give you a lot out of the box, and the part of Crossplane that we use here is this composition engine. So what does the composition engine do? So it sits here, that they provide this control plane, and the composition engine sits here as a way for us to have custom code that allows us to then essentially enter the process of how Kubernetes creates resources. Essentially, this is you, right? This is your user. And when you run Azure Workload Run, you essentially create this request. We create that custom resource that we saw, that workload that I showed earlier. And then that kicks off this composition engine. That's where our actual Azure code lives. And then it interacts with the API from Kubernetes. So it might create deployments, services, or eventually instances that are managed by these cloud providers. For example, we can create an RDS that's managed by AWS. And this is all out of the box with Controlplane, this integration. And essentially our focus is here on the composition engine. So this is a composition, meaning you can actually have multiple functions working here. We built just one, but you can actually have complex composition still. How does this work? This essentially, you can visualize this as a pipeline. They call it composition and also pipeline. So it's a concept that's a little bit mixed here. But essentially, we go from the observed state, the current state of our cluster, into this desired resource. And we go through all of these functions. So some function might do validation, making sure that your resources, the resources that you're asking of Kubernetes are within reasonable limits, so you don't blow out your budget. You might have something that adds sidecars for observability, for example. That could be another function, or a bunch of other stuff. There are a couple of functions that are out of the box, mostly around replacement, right? You have a YAML for Kubernetes, you replace it, replace a couple of values, and you end up with a more complex YAML. That could be one. Here, we actually built our own custom function in Go to be able to actually have more complex logic. And this is what happened, right? This is our input. Again, this is what comes from Azure Workload Run. We provide this X workload, right? Which has, these stages are automatical, like this metadata doesn't matter here. And we have these things that are going to be created based on all the information that I provided. So our function interprets this and then builds the actual detailed resources, the deployments, the services, the pods that Kubernetes actually needs to create. This is essentially what we did when we ran that workload file. So let's go over what's actually happening on that function. What does that function actually do? Because a lot of stuff happened here, right? This was quite quick, but a lot of stuff happened. We had resource injection, right? Environment injection. I'm injecting information from a bunch of different places here on my application. I am creating proxies, so things are exposed. I'm also creating a bunch of complex resources, right? Postgres is not something you initialize just like that. I'm also doing initialization script, which in Postgres is relatively straightforward. Other resources are not and involve more logic. And I'm also linking to another workload, this workload here, which was also launched. So let's go over the workload file. So we have these three sections. We have the containers, we have the service, and we have the resource. These are the main sections when you're building this workload file. The containers are pretty much a generic definition, right? You have images, you could specify resources, and we're going to expand that to provide more functionalities in the future. But it's essentially what you would expect when you launch something in Kubernetes or even just locally with Docker. You will provide those usual things that you can see in the documentation. The services, they are pretty straightforward. You specify what is exposed. And this is going to end up being a service in the cluster, like you would expect. Then we have the resources itself. This is where the more complex part is, because here you provide very little information and end up with a lot of complex resources being created. And this is kind of where the value of this tool is as well, because a lot of these resources, you don't care, right? You want the database there. You might have specifics that you want, but most of the time you just want a database. I want MySQL, I want this version, that's it. And you don't need to worry about a lot of configuration. And this also allows you to play around quite a bit. because you are isolated, right? You are in your own namespace, you have a dedicated database. This is what a true feature environment is, a true ephemeral environment is as well. And we start that pipeline that I showed before, right? We give it this workload file and we go through this function. And the run function is this essentially gets the request with that, and we're going to output our response, and that response is the desired state, so what we actually want. And very high level, this is what the function does. We get our custom resource and the custom state of the cluster, what we have right now. And then we get our desired from the previous function. So remember that this is a composition. So this function will output something that this function needs to preserve. Otherwise, it will be lost. It won't reach the end of the pipeline. Then our custom logic here, we get this workload from the request. It's in the request itself. We create these resources. They create an environment as well. So this is something like when I created this Postgres, right? Postgres is authenticated. There is a username, there is a password. That password needs to be injected here. And essentially, that's what this environment does. All of these variables that are needed for you to actually access the resources created, they end up populating this environment. And then they are injected when you are creating the container. This is a string interpolation that you can use when you're specifying the YAML file, but this is what's happening. When we create resources, we get some of these information. For example, passwords are randomly generated, so we don't run the risk of sharing passwords everywhere and not knowing what they are. They're randomly generated, and they're added here to the containers as well. Then when everything is created, we expose the ports, we send it to Crossplane, and then Crossplane has the responsibility of interacting with the different Kubernetes APIs to actually create the deployments and the services and the pods. We tell it what they need, which pods should be created, which deployments, which services, and then Kubernetes handles the actual creation loop. So, and how does this function look like? So we started with our composed state. So we have the observed state, our desired state. We get this workload, and then we start adding resources. In order to expand, so we started with 2 or 3 resources. We're now over 10 resources. That includes local resources like MySQL, Postgres, and Redis locally, but also include resources on the cloud. We support MySQL and Postgres on Cloud SQL. We also have Kafka as well, and we have a bunch of different resources. So this grew a lot. A way to kind of make this manageable and something that can be expanded in the future and eventually can even contribute to it as well is we introduced this microkernel pattern. So all resources respect this interface, which then we can do a simple chain of responsibility to go over each resource and tell it and leave the creation to it, right? But each one will have to respect this interface. So it will have to be able to build an environment, and it will be able to create a list of desired resources based on the current state and the desired state. On this current state, we'll have this workload as well. On the desired state, it's essentially what was already created. Because remember, this always has to be cumulative time over time. And this is most of the work of this specific part of issue during the last month. So adding all of these resources, adding all of this compatibility. At this point, most of what you need on normal development day-to-day, we have it here in a way that's easy for you to integrate with your application. So you can build your image, you can launch a bunch of these resources, and you can inject to it. And then you can play around, right? Let's say you want to move from MySQL into Spanner. You can play around. Let me use a Spanner resource, and let me try to start using that. And let's see what works and what doesn't. If I want to introduce a Redis cache, how can I try that wrong? And we can do that as well easily enough. So you might start questioning yourself right now, which is, I can do all of that with Docker Compose as well, right? I can launch everything locally. And that's true, you can. The big difference is how fast you can do it, because essentially, Docker Compose, you will have to specify everything, which might not be an issue for you. You can use LLMs and simply generate it. That's fine. But also, there's the other part is how are you going to share it, right? Here you can share it with other people because this is on a remote cluster. And the interesting problem that we found while developing Eshu, and even more pressing today, is how much can your computer take, right? How many resources can you actually create before your computer starts becoming a difficulty? And here you're offsetting the computation to the remote cluster as well. So you can focus on what you're doing, right? Because personally, when I'm developing on Eshu, if I just want to test Eshu, I launch it locally, I run it, and if I don't have anything heavy going on, if I don't have IntelliJ, if I don't have lots of things on the browser, then everything works. But when I start running things on IntelliJ, having local applications that need to be built time and time again, when I introduce LLMs as well, which take their computation as well, then my computer starts crashing down, either by CPU or by memory. So for those of you that actually have these monstrous applications that take up a lot of resources, offloading some of them is a big plus on itself that you can use here. So environment injection, that's another key part of it. So how do we integrate all of this? Because like I said, you're not providing a password. I'm just saying, I want a Postgres, it's in cluster, I want to initialize it like this, create me a database that's called like that. But here, I know the host, I know the database, the passwords, the ports, all of that. So how does that get created? Well, essentially, a lot of these things are randomly generated, like passwords. Some of these things are static, but there is no guarantee. This is kind of to push you into doing best practices, which is not, don't hard code anything, right? You just use environment variables as anyone. So these things need to be generated and kind of push you to do that. And that's what we do. And then we have to inject them. And this creates a natural order in the way things get created. That's something we learn over the course of developing. Because we need to create all of this, we need to make it available, then we interact with secrets, all of that. But all of these get then injected. Like I said, this ends up being string interpolation. You can do that. You have these resources. You have the name of the resource that you want. In this case, DB so this chat application. We go back to it. So this is resources is DB. This name is essentially what I provide here. This is the name that I use, and then the list of available environments. Variable. And this is standard. Most of these are what you expect. You can check the documentation on Eshu that we have for the actual list for each resource, but this is essentially what you can expect. And when we're building this, all of this gets injected so you can actually use on your development. Lastly, one other thing that was important here, and this is kind of a middle step to the future, is joining different workloads, because you're developing your service, right? And you don't exist in isolation. You depend on other services. And you want to be able to test all of this locally so you can play around. And for example, let's say I have a service that my chat application depends on the identity service. What happens if the identity service goes down? How can I simulate it going down for a little bit? What happens? Bring it back up. All of these little different tests and experiments that I can do. You want to be able to do them on your machine and see what's happening, so you can actually develop a lot of these cases. And for that, we need this concept, these different workloads. And for now, a workload is simply a workload of another service is simply another YAML file that you can use, and you can launch by having that YAML file, and you can ask your downstream team to actually share it. So you can ask them, give me your service, or they can have it on their repo if you have access to it, and you can ask it and launch it as well. Eventually, in the future, this can be expanded. We could have a catalog of it, and there is a lot of room for expansion there. But at this point, you already have the functionality that you need. You can have all of these different things. And then you have this special resource, this service resource that we see here. The service resource essentially exposes the host and the port, making sure that everything else on that workload is not accessible. So even though I have on my cluster, where are my pods? I have two databases. They're isolated to their specific service. And at this point, they are all part of the namespace you could access, right? Like it's on the same cluster, you could always access, but you're not going to have the variables there. So if I actually go into here and I would do something like identity user, username, this is not going to be resolved. This is essentially hard-coded what you're going to have. We're going to have this as a string. This is not going to be resolved into the actual username. So, and this is, again, another way of us to give you all the options, but always push you towards best practices. So these things are isolated. Don't share databases. Don't share resources that are not yours. But you need this interaction. You need to be able to reach the service. So that the identity YAML here, so the team that I depend on, they provide what they're exposing, and these things are injected. So I can use the port, I can use the host, I can reach the service. If they have internal services that I'm not supposed to reach, they simply don't declare it here. I can't access it. So what did we learn over the course of this? What are some interesting lessons that I can share when we are developing that? One of them interesting was we randomize a lot of information. So password generation, port generation, to make sure that you don't need to worry about clashing ports. You don't need to worry about, you have passwords being rotated, so you are forced to use these environment injections. But Crossplane, like Kubernetes in general, has these loops of trying to make sure that things exist. So, right, if I go here, say this is my workload, right? I'm going to go here and I'm going to delete my identity pod, right? This thing gets created again. This is normal Kubernetes behavior, right? My workload goes through the same thing. So this workload, this function, this pipeline that we saw before keeps getting run, right? So if my workload has any type of change, the end result, that desired component result, is going to change as well. So what we found happening was I randomize the ports, for example, right? So I randomize the ports during the pipeline. And when we reach the end, okay, we have this set of ports, we created the proxy, everything looks good. When the next loop happened, the ports were random again. And so when it reached the end, Kubernetes changed the service of the pod, changed the service of the resource, right? So a new one was created, and it broke the proxy itself because the port changed, and so resources kept getting started again and again and again. So we needed to introduce this concept of reaching a steady state when we develop our function. So we don't need to be static. You don't need to generate the same thing, but you need to reach a type of steady state so things don't keep changing over and over again. And this is something that we learn the hard way by building workloads and then seeing that the workloads stop working all of a sudden or kept restarting. And essentially now we got this by looking into what we already have. So what ports do we already have? If we have that port, we keep using it. If not, we randomize. And this is kind of the philosophy of a lot of these generated things that has worked very well so far. Another interesting tidbit that we found is there is a lot of possibility of clash. So I have two workload files, right? I have these resources. And what if I call it the same thing? What if I call it here DB, and here I also call it DB? I can't just come here and launch two DBs on the cluster, right? Because they are the same name. So we needed to start composing these names from workload name, resource name, port name. So we had to start composing a lot of these names together. And the thing is, Kubernetes on names, on labels as well, has limitations, the number of characters you can use. So this is something we also had to kind of catch, because it's not something we thought about first, because first we just wanted to build it, then we started composing the names, and then we started running into these limitations. And this is something that we're still kind of working a little bit today to make sure that you actually have something that's understandable. Here we have this, which is essentially the composed name. So PG was the name that I gave to the Postgres resource, and this is the name of the port. And it's kind of, if you put a long name, what happens is we start cutting off parts of the name. So it still fits the Kubernetes rules. So that's something we'll still work to kind of have a better way of showing you these names so you can see it. But it was also an interesting limitation that we found here. And personally, I listed here a couple of things that I see as the main benefits to using Azure Workload, and I hope you can find some of them yourself and use them as well and provide feedback so you can keep improving the tool. Some of them were like, we could launch a lot of complex stuff a lot easier, especially if you change. Like if you have your resource and you're never going to change them, you might say, I just configure everything and then I launch it. But if you want to keep changing and try different things and testing, this is probably an easier way to do it. And especially for feature environments, which is something I don't think we do a lot here, and prototyping in general, this is going to be a very useful tool to it. And I hope you try it and use it, and you'll find it as well. Another thing is, like I shared before, computation is done on the remote cluster. So that means you can use a lot of more resources on your machine, which is helpful as we get more complex tools like LLMs. You can just offload some of these resources that you're not developing. For example, today when developing Azure, I have a workload for parts of Azure that I need. They are put on this remote cluster, in this case Omega, because I have more visibility. And then I develop Azure locally with it. I launch parts of it that I need, and that computation is there. If I had to launch everything on Azure to develop, and I did it in the start a couple of times, it gets very complicated, and my computer crashes 4 or 5 times a day because of it. Another thing is this unified functionality. So I showed you Postgres, right? And Postgres, you might know, can be initialized by simply putting a file with the initialization script. But what about other tools? What about Cloud SQL? I don't think Cloud SQL you can do that. So, but the functionality is in there. For you, you just say, I want to initialize with this script, but it's not something that's a functionality out of the box. So by having this abstraction, we could start giving you these extra functionalities of these resources where we handle under the hood. Essentially, we run a job after the resource starts that connects to it and launches everything that needs to launch. And this is something you don't need to do yourself because you don't care about it, right? You just care, I want to test, give me that data seed, and that's it. And because of this functionality, we could start giving you those little quality of life things. And lastly, right now, this is as YAML sharing files. Eventually, it could become more complex than that, but it's something you can do right now. You work with another team, give me your workload definition, tell me which image you are using to try that new feature that I want to test or whatever, or how can I create this state? What if I use this identity service and there are users with corrupt data? What happens? How can I test? How can I replicate this bug that I found on production? And you can do that by having a lot more control, because essentially with this, you have more control of what gets created. You have can go inside and tweak things a lot more because it's locally, right? You have all the access that you need. And that's it from my side. I hope this was useful to you and you learned a bit about how we built this. This essentially is a little bit of platform engineering, right? Of creating these tools for you guys. And yeah.